Alright, let's dive into something that's both fascinating and a little unsettling: AI models that are way too confident in their wrong answers. Yeah, you heard that right. It turns out, even the most advanced large language models, LLMs, can spit out responses that sound incredibly convincing but are, well, completely off the mark. And here's the kicker: they're often confidently wrong. This isn't just a quirky AI behavior, it's a serious issue, especially in high-stakes fields like healthcare or finance, where a wrong answer can have real consequences. Now, you might think, okay, so we'll just ask the model to double-check itself, right? That's actually a common approach. Researchers often test an LLM's self-consistency by asking the same question multiple times. If it gives the same answer, it's assumed to be confident. But here's where it gets tricky: confidence doesn't equal correctness. A model can be dead wrong and still insist it's right. Personally, I think this is where things get really interesting. It's not just about the model being incorrect, it's about the illusion of certainty it creates. And that illusion can be dangerous. Enter the researchers at MIT, who've come up with a new method to tackle this problem. Instead of relying solely on a single model's self-assessment, they're comparing its responses to those of other similar models. Think of it like this: if you ask ChatGPT a question and it gives you one answer, but Claude or Gemini gives you something completely different, that discrepancy flags what's called epistemic uncertainty. What makes this really interesting is that it's not just about the model's internal confidence, it's about how well it aligns with what other models think. In my opinion, this is a game changer because it shifts the focus from "how sure is the model" to "how sure should we be in the model?" Now, let's break this down a bit. Epistemic uncertainty is essentially about whether we're using the right model for the task. But here's the catch: there's no such thing as a perfect model. So, researchers have to use approximations, which often come with their own set of assumptions. What the MIT team did was create an ensemble of models, a group of LLMs with similar sizes and architectures, and measure how much their responses diverge from the target model. They focused on semantic similarity, meaning they looked at how closely the meanings of the responses matched, not just the words themselves. This, I think, is a brilliant move because it gets at the heart of what we really care about: the accuracy of the information, not just the model's confidence. One thing that immediately stands out is how they chose the ensemble. Instead of overcomplicating things, they opted for models trained by different companies. Why? Because these models are diverse enough to provide meaningful comparisons but still similar enough to be relevant. It's a simple approach, but it works remarkably well. And what this really suggests is that sometimes, the most effective solutions aren't the most complex ones, they're the ones that address the problem from a fundamentally different angle. The researchers combined this epistemic uncertainty measure with the traditional self-consistency approach to create a total uncertainty metric, TU. This metric outperformed other methods in identifying unreliable predictions across 10 realistic tasks, from question answering to math reasoning. What many people don't realize is that this isn't just about making models more accurate, it's about making them trustworthy. If we can't rely on an LLM's confidence, we need another way to gauge its reliability. TU does exactly that. But here's where it gets even more intriguing. TU doesn't just flag wrong answers, it can also help reinforce correct ones during training. If you take a step back and think about it, this could lead to more robust models that not only avoid overconfidence but also improve their performance over time. Plus, measuring total uncertainty often requires fewer queries than traditional methods, which means less computational cost and energy consumption. It's a win-win. Of course, no method is perfect. The researchers found that epistemic uncertainty works best for tasks with a single correct answer, like factual questions, but might struggle with more open-ended tasks. This raises a deeper question: how do we adapt this approach to handle the nuances of creative or subjective queries? Personally, I'm excited to see where this research goes next. Maybe we'll see hybrid methods that combine epistemic and aleatoric uncertainty in even more sophisticated ways. So, what's the takeaway here? In my opinion, this research isn't just about fixing a technical glitch in AI models, it's about rethinking how we measure trust in AI. Confidence is a poor proxy for correctness, and relying on it blindly can lead to serious mistakes. By introducing methods like TU, we're moving toward a more nuanced understanding of AI reliability. And that, I think, is a step in the right direction. But I'll leave you with this thought: as AI becomes more integrated into our lives, how much should we trust its confidence? And more importantly, what does it mean for us if the machines we rely on are often wrong but don't know it? Let me know what you think in the comments below. I'd love to hear your perspective.